Alrighty, so here's one I've been trying to do a few times, but people keep coming in while I'm doing it. And you'll have to forgive the bell noises, but the cows in the background are doing cow things. This is Delboy's Garage. Now, Delboy's Garage is one of those channels. It's a motorcycle channel. I'm sure that Matt Hudson's torn this one to bits. Yeah, it's a motorcycle channel. And Del is just the master bodger. He's terrible, and he'll tell you that everything he does is perfect. And at this point, he is currently trying to fix up a rather broken and bent Goldwing. He's trying to monoshock it. Part of monoshocking it was a bit stupid, really, because it was already monoshocked, but he's trying to fit a sports bike type suspension system to it, with hilarious results. His welding's terrible, but I'm not a very good welder, so I'm going to refrain from talking about that. Anyway, here we go. This is Delboy's Garage. He's doing some machining. And if are we still going? Yeah, we're still going. Right, okay. Whoops. No, I'm going to skip through some of this stuff because yeah, we don't need to see him making his whiteboard. Come on, stop that. Yes. I'm sure Winston Churchill.
Right, good morning. Welcome back. Back on the Goldwing project. Now, in the last video, if you watched it, we've got the short link mechanism mounted on the frame, and I've now got to make some sort of way of mounting the other end of the link plates to the swinging arm, so that the swinging arm and the frame are then connected for the suspension to be functional. So for the next step, I've got to connect it to the swinging arm in the same way it's connected to the frame. So it's got bearings in it and it functions up and down all completely accurately in the same exact plane of travel, and everything is safe. And at the
right, all of what he said is true, and it's also utterly false because none of what he's doing is safe or in the same plane of travel. But yeah.
moment, there's nothing on the swinging arm whatsoever to connect it to. I've literally got to create it from nothing. So to give you a quick preview of what it's going to look like, if none of this really makes sense at the moment, I'm just going to take the old shock absorber and shove it up through the frame so it's in situ, offer it up to the linkage, and then you can see, hopefully, through the swing and bolt through there. If you're sport, you see.
Don't care about this, Del. Come on.
I've connected into one across the top of the frame, but for today,
get on with the funny, come on.
On the short link mechanism itself. It's a big chunk of metal with a hole right through the middle to put this big 100mm bolt through. And the tolerances and width and diameters of everything I've got to create is exactly the same as everything here, because the two link plates have to be absolutely parallel, exactly the same. So I can take all my measurements off the short link and create them again here and then weld them to the swinging arm.
He used the word tolerances, and I don't think he knows what the word tolerances means. But yeah, we'll carry on. He doesn't know what the tolerances are on that piece. He could look them up for what he needs, not from the part itself, but for the bearings that he's fitting. But yeah.
But it's not as simple as just a chunk of metal with a hole through it. There's an awful lot more to it. So if I just take this bolt out and whip these plates out the way, I'll show you inside here and exactly what's in there and what I've got to recreate. There are actually 5 components that live inside this piece of metal: 2 needle roller bearings, an inner bearing sleeve and 2 seals.
It's not a bearing sleeve, it's a race, and it's also the spacer for the link plates, dog bones, whatever you want to call them.
I'll show you. Right, first, this sleeve forms the inner race bearing surface, so that's hardened and polished and all that. No way I could make that.
Quite right.
I've had to order one of those. And next we've got a seal. Lives there, keeps the water out of the bearings, and there are the 2 needle roller bearings that the inner sleeve rolls against.
Right, these are totally stock needle roller bearings. They're 2026s, They are a 20mm internal diameter, 27mm external diameter, and 26mm depth. What Del is going to need to do is make this hole very accurately to fit, to take a press fit on this, and press fitting these in is not trivial. He's also going to need to make a mandrel for fitting them. He's going to need to bore to the correct depth with the correct finish on the inside. I don't think he's going to manage to do it.
And with that sleeve in situ between the two bearings, the bolt that holds the plates in slots through the inside. So that's how the whole system fits together. And I've got to create that exact thing there with bearings in it and seals and one of these on the swinging arm there in the right position, accurately, upright, square, level, like all the rest of it, so it actually functions. Now it'd be very easy to just contact a local machine shop, give them the sizes, in fact give them that, and then just say machine me one of them, that width, that diameter hole, exactly, because it's got to have a bearing put inside it, and they'll do it. And they won't even charge you much. I reckon they'd charge you about 50 quid for doing that.
Well, that's what you should do then, Del, because what you're going to do is not going to be anything like what a local machine shop is going to be able to do.
And then I can just weld it on. Great. But there's no fun in that, is there? I want to do it myself. I've got a hobby lathe. I've got all the patience in the world. I've got some metal I can use.
You haven't got all the patience in the world, Del.
It's got to bore a hole in it, and then I've got to weld it on. How hard can it be? Well, it can be quite hard, actually. I'll tell you why. Right, now the hole I bore in this piece of metal has got to be a critical size because the bearing presses in with an interference fit, as we all know, and that means the hole has to be smaller than the bearing. The bearing is 27mm. I've looked up the size of the hole that I need to bore. It is between 26.96mm and 26.985mm with an optimal size of 26.97mm. So
yeah, it's 30 micron press fit. That seems maybe a bit tight. I don't know. I don't know the exact specs for what that goes in, but it sounds within the bounds of reason. Yeah, 30 micron press fit. That'd be, yeah, in fact over the diameter. Yeah, it's not very much. Yeah, that's almost certainly correct. Although I guess he's got it from ChatGPT.
the hole has to be 0.03mm smaller than the bearing for it to press in. Too big and it will fall in and it won't work, and I've buggered it. Too small and I can't get the bearing in and it will risk crushing it trying to get it in. So I've got to make that hole absolutely correct, 26.97mm. Now
There's something else you have to do, Del. You have to put one in either end, and they need to be absolutely concentric, because if they're not absolutely concentric, you're going to be in a world of hurt. Yes. Are you sure you're going to be able to do that? Have you got the tooling to do it? I'm not sure.
drill bit that will drill that hole. I've got to drill it out to about 26 and then machine the last 0.97 of a mil off with an internal boring tool on the lathe.
Right, okay, I think he's messed out his editing, but now he's got a piece of steel that looks a lot longer than 85 millimeters. The way that you should go about doing this, I think, is to cut down your piece of stock to almost length and get it down to length first off with faces which are absolutely parallel. I would then centre pop it. In fact, I'd probably centre pop it first, but yeah, run it between centres and skim the diameter so that you've got a known diameter which is central, which is parallel to the central axis where you're going to drill. Then set up in the forejaw to do the drilling. The centre hole all the way through doesn't need to be particularly tight tolerances, just needs to be bigger than 20. You could probably drill it out to 22, that would be fine, you could leave it at that. The rest you need to bore out to the right depth, which is going to be 26 plus the depth of the seal seats. yeah, you just do that from boring. So go 22 and then bore out, flip it around, again, indicate it square, do the other side. Now, I'm not sure that Del has bore gauges. I'm fairly sure he doesn't have a bore micrometer. He may not even have an outside micrometer. So I hope he's not going to try and do this using his Chinese calipers. That would be rather bad, wouldn't it? Right, let's see where he goes. So he needs to measure this, and he needs to measure the depth of one of those seats, or he could calculate the depth of one of those seats.
That's the task. 84mm wide.
Well, no, that's not 84mm wide. That's 84.15mm wide, Del, and that's definitely longer. That's got to be 110mm. So the first thing to do, chuck it in your bandsaw, lop off the end. You're doing this in a 3-jaw. Okay. Right, let's see how square that runs, shall we? I'll piss off with your vertical thing. You know it's the right height. Ooh, see that kick when he first cut? Now then, you can see how much it's running out here, and as soon as he cut, that moved. I think his lathe's in a bit of a state. It is a small Chinese hobby lathe. He could do with his support being here to give as much rigidity as possible. This machine has fuck all rigidity, so yeah, okay, carry on, Del. Mind you, at least he's using carbide. He's getting a horrible finish, but it's mild steel, that's to be expected. What are you facing it off for? Cut it off. Cut it off. Big enough centre drill? Take the lid off. Yeah, waste as much carbon. Right, let's go back a second. Watch that drill wobble once it kicks. So it's probably to do with his tailstock not being 100% on centre. Could be that his centre drill is badly sharpened as well. But just banging it in, not such a smart idea. So he's already off centre. So as it hit, I'm pointing at the screen again, as it hit, drill goes up. What that means to me is that this flute here is engaging before the other one, and it's pulling you up and out. Yeah, okay. If you really care about making this central, well, you don't really at this point, but if you really care about making this central, you put it in a, what do they call it, in a steady rest. Right, flipping stuff around in hard jaws on a 3-jaw chuck. For the moment, still not really a problem, as long as he's going to put it between centres. Is he going to put it between centres? Who knows? Again, see that rider. Okay, you're going to drill through with an 8mm drill. Why did you bother centre popping the other end if you're going to drill straight through that hole? Also, your drill is probably not going to be long enough. That's an 8mm drill. That's probably got, what, 84mm flutes, something like that. You get through if you were cut to length. Otherwise, you're going to have to plunge in with the flutes buried or flip stuff over. God, no, that's what he's going to do, isn't it? This is all sorts of wrong already. At this point, he should be between centres and skimming the outside so that he's got a reference surface to work from. And it should be cut to length. Fuck it. Yeah, flip it. Flip it and flip it and flip it and flip it. Okay, good way to get really accurate results. Remember, you're looking for 30 microns, Del, something that you can barely measure. Now you can see the drill wandering. Again, not particularly a problem at the moment, because all you need to do is drill through to the thickness of the core of the big drill that you're going to poke through the middle. So, although your machine's probably not strong enough to go in with a 22mm after this, you probably need to go in, I don't know, 14, 18, 22, something like that. Ooh, and that kicked something rotten once it punched through. That's because both holes are off centre once they get in there. Normal, drills wander.
Right, taking it really easy with these drill bits. I've only got that one piece of steel that's long enough in length and wide enough in diameter to bore the hole through and produce the piece of steel that I need.
Del, you're making money from your videos. You can go out and buy a piece of steel that's like 10 euros worth. You could go to a material shop and buy another piece. You don't need to piss about.
Snap a drill bit off inside there.
Your machine's never going to snap a drill off.
And can't get it out. I've buggered my chances of doing anything meaningful today. So it's brand new drill bits every time. That was an 8mm.
Brand new drill bits, and we just throw it in the box. Bling, bling, bye bye cutting edges. Ah, it makes my skin crawl.
This is a 10mm, gently does it. Just work them through and take the hole out to 25mm. I've got a 25mm drill bit, I'll work my way up to it, and once I'm...
Why are you going out to 25, Del? You only need to go to about 22 to get clearance for the inner race, and then you bore the ends. You're not just going to do the whole damn thing, are you? Oh God, that would be funny. Okay.
At 25, and get the boring tool in there and fine tune it to 26.97 if ever I can achieve that.
Right, this is boring, and I suspect, well, it's not boring, it's drilling. I suspect it's going to involve lots of flipping the part and going from drill to drill to drill, so we're going to skip. Let's see what we get to. Yeah, flip the parts. Drill. Yeah, bigger drill, watch that vibe. Every time he puts it in, it's wonky in a different way. Oh Lord.
We go up to 18. Slow them
down,
good. And that just involves swapping the belts onto different...
That's something you should have done earlier, really, because you did look to be going quite fast. But, you know, they're only cheap drill bits, aren't they? And I'm sure that you can sharpen them. I've seen your drill sharpening video. Right. Yes, change the belts, Del. Make it run as slow as possible because, yeah. Oh God, shitty music as well. Bloody marvellous. No, stop with the music. No. Oh God. So I assume that he's now gone all the way through at 25 mil. That is not smart, but hey. Oh God, cleaning up, yes, okay. Yes, clean up, Del. Good, good, good. Clean up, good, good, good. Oh, turn off your fucking poxy music.
Hole currently measures 24.75.
Right, okay, that's a good indication of how accurate calipers are for measuring the internal diameter of a hole. He's just poked a 25mm drill through there. It will have cut over size. You're probably close to 25 and a quarter, something like that. He's trying to measure with his calipers. Now his all calipers, no matter how good they are only really guaranteed to be accurate to about 20 microns, 25 microns. He wants to get something to within 30 microns. He's measuring undersize already. Let's go back for a second and see what he says again. So,
ready to go. The hole currently measures 24.75.
Yeah, you're measuring 1/4 of a millimetre undersize for something that's probably 1/4 of a millimetre oversize. So you're out by about 1/2 millimetre.
The metal's stone cold again, so I'll get an accurate size.
No, you won't, Del. Check your precision. The precision of that tool is plus or minus 0.2 mil for measuring outside diameters. For measuring inside diameters, all bets are off. Depends whether you've got it a bit wonky, whether you're absolutely square onto the hole, whether you're going onto the centre of the hole, or just no, it's not the right tool. You need snap gauges and you need a fucking micrometer.
I know what it is. I know what it should be. I've got my own cutting tool which I made because...
Oh lordy. Now that looks all sorts of fun. Del doesn't know what a boring bar looks like, clearly. Oh my word. Okay. And I'm seeing here guffs on it. That's interesting.
My pre-made tips, I haven't got a tool that will get in there.
Yes, so if you haven't got a boring bar that will go into a 25mm hole, Del, you need to go and buy some boring bars. They're really, really not expensive.
To a 25mm hole. I've made one which I've ground the underneath away so it fits in there. So hopefully I'm ready.
Dear oh dear. Right, you could do with looking at some tool grinding videos, Del. That's all sorts of the wrong tool.
Ready to go. Very gently, a tiny little bit at a time. I'm going to see if I can take that out to 26.97.
Oh yeah, look at that. See that there? He's already run this, and he's run that up against here. The reason for that is because he's got his tool angled. He's got his tool angled so that he can get the cutting edge, because he doesn't know how a boring bar, what the geometry of a boring bar should be. In fact, you can see the finish that he's got from it as well, because it's got a nice sharp corner, no radius. So he's jammed that in there, and it started to gall up on the other side. So this promises to be quite amusing. Is he going to get the full 26 plus the depth of the seal that he requires?
Okay, 25.1.
I can guarantee, Del, that if you went in with a 25mm drill, that hole's bigger than 25.1. Oh, nice depth stop as well. Very nice. A little bit of magic marker on there. That's very precision. Definitely to the micron. And you've gone past it.
Right.
It's getting a horrible finish
pass. 26.3.
Alright, you think that you're going to get to... No, this is just too funny. No way you're going to do this. Taking some pretty big cuts.
26.64. Just a shave more.
No, that's not a shave. If you're at that kind of... good Lord. Snap gauges, Del, snap gauges. They're not expensive either. And for the love of God, get some bloody tooling. And learn about spring passes.
26.88.
26.88. Eh? Okay, that's what you reckon, is it?
0.1 of a mil. Right, it's all cooled down now. The bearing goes in with
it's quite cocked. Putting those in, I believe the tolerance for putting them in is 1 arc minute of misalignment. That's very misaligned. I suspect he's overshot his hole and he's trying to pretend that it's difficult to put in.
firm finger pressure. Wiggle it in, and it literally gets about halfway and it stops. From then on...
Right, it probably gets halfway and it stops because your machine was vibrating so much and you've got a horrible surface finish and you're cutting on a taper. That's possible. Yeah, that's extremely possible. Pushing that in is going to be fun though, unless you make the correct mandrel for pushing it in.
I'm going to need to press that with a die, so that's perfect. That's an absolutely bang-on interference fit. I'm really happy with that. I don't want it in there yet because obviously I'm going to weld on this and it'll get too hot, destroy the bearing, so I'll just take it back out. And the other thing is...
That's an interference fit, is it? You just pulled it out with your finger. Your interference fit.
Is a little bit more of a test is the rubber seal that goes on top of the bearing. That fits. It's a bit like a fork seal. It's got a metal liner inside the rubber and that pops in absolutely perfectly like that. That's bang on. It's exactly how the others fit into the mechanism, so that's perfect.
Yeah. Come on,
I've done that hole absolutely right.
Yeah, suck your cock, mate. Done that hole absolutely right. You're really pleased with yourself, aren't you? Okay, so presumably it more or less fits. All right.
Really happy with that. Now, obviously this is too long, so I'm going to part the end off it and then do the same as that on the other side. Let's go. Okay, needs to be
84.15. 84 point.
Yeah, that's 84.
No, it's not 84. It's 84.1. It's not actually that necessary to be. It's not such a huge deal. It's not something that's in contact I mean, you don't want to be millimeters off, but 84, 84.1, yeah, I reckon he's all right. He's within, you know, within the bounds of reason. But to measure something at 84.1 and then say, oh, that's 84, yeah.
All right, 84.
Okay, that's interesting. Now again, like I said, you should have cut this off to start with. Taking it down to length should have been step number one. It's quite brave trying to part it off on a wobbly Chinese lathe that far out from the chuck. He's not flat up against the chuck anymore. Yeah, you can see the piece walking. So as his machine is vibrating, that vibration is slowly walking the piece out of the chuck. It's because the machine itself is not rigid. Yeah, he's probably getting on for 0.5 millimetre out of the off the back of the chuck now.
Perfect.
Perfect, is it, Del? Perfect. To within, yeah, it's close enough. Close enough, I think, is the word I would use. And are you going to break those edges at all? Probably not. I'm not seeing any measurement of depth going on here. I think he's just winging it and hoping that they're going to stay in place. It's not what you should be doing. They do need to sit up against a shoulder. And measuring stuff with fucking calipers. Cheap Chinese calipers.
Right, 25.3. 26.03. Try.
Why are you trying your bearing in there? Why are you trying to put a brand new bearing into there when there's chips and cutting oil and shit all over the place? Because you don't trust your measurement tools, do you? And you're right not to trust your measurement tools, but that's not the way that you should do it. If you were going to go that way, you make yourself a go, no-go gauge. Although again, go, no-go gauge requires you to have a micrometer.
26.57. Getting there.
It was a bit of a waste of time trying to push the bearing in then, really, wasn't it? If you're already, if you're the best part of 0.5 millimetre off. There's press fits and there's sledgehammer fits.
Okay, 26.74. Yep, I reckon one more.
That's a pretty big pass for a one more. 7.4, you need to be taking off 1/10 of a millimetre. Just over 1/10 of a millimetre. That looks to be more than that. Of course, quantity of crap that's coming out of there. That was a pretty big cut.
Test.
Again, he's in wonky. You can see it's much tighter in this side than that side. That's a your mum fit, that is.
Perfect.
Oh, we did break the edge. Okay, all right. Give him that. Whoa, that's a bit fucking big. All you need to do is break the edge, Del. Your seal's got to sit on that, and it's only got a couple of mil. Right, hang on for a second. I'm going to go back. Right here, he's just pulled the part out of the chuck. There's all sorts of shit here. Does he clean it? Make sure that it's not sitting on swarf? Does he? Fuck. That fucking badger. And you can see by the way that the edge is moving here that it's not running central. I mean, you can also see it up here, but you can see the effect by the way that his chamfer here, which is 50 times too big, is thicker on one side than on the other. A lot of this is down to the rigidity of the machine, but it's also down to the fact that he's using a 3-jaw chuck to try and do this and try and get these concentric. There is absolutely no way that that hole there is concentric with that hole there, so even if he'd hit the dimensions he wanted, he's already fucked it.
And after a long day, there we are, all done. That is exactly what I intended.
After a long day, okay. Yeah, I suppose if you spent half the day pissing about with drill bits.
To make. The holes both ends are absolutely perfect for the bearings.
Are they indeed? Absolutely perfect for the bearings. I bet they're not.
They fit in.
Yeah, again, pushing it in sideways, pretend it's difficult.
A little bit of force by finger, and then they stop dead there. So that will need pressing in from that point, which is exactly how it should be. And I'll probably even put a little bit of
pressing in. If it needs pressing in, you can't pull it out with your finger, Del. Yes, you're going to need to put some block press in there because they're never going to stay in place. But yeah, you need to make up a mandrel to push those with as well.
Red lock around the outside of the bearing just to lock them in place for belt and braces, and also the seals, both sides fit perfectly into the outside. So both of the new bearings will be completely protected inside those brand new rubber seals. Perfect. And also the width of this has to be precise as well, because this central sleeve that fits in through the middle has to obviously be wider than this, because then when the two link plates clamp down onto it, they need to be able to rotate 8mm, 2mm either side. Perfect. So that's it for today. If you're new to the channel, then maybe consider subscribing. We post videos up like this twice a week.
Right. I'm saying that he's a liar on this. If he was happy with his fit, he would have shown the bearings going in both ends. He's not happy with his fit. He's deliberately pushing them in sideways to pretend that they're difficult to get in. The fact that he can then pull them out with his finger without trying is good. But his tooling, that was really quite something. Del, get yourself some snap gauges. Get yourself some micrometers. I'm sure that Seeley or Clark will sub you some if you were to ask. And get yourself some boring bars, for fuck's sake. Insert boring bars, they're really, really cheap. Anyway, there you go. Delboy's garage. He's special.